All right. Good afternoon, everyone. Welcome back. So today, what we're mainly going to focus our energy on is rates. So we're going to practice writing our fractions using the numbers and words, as well as reducing those fractions either by taking out common factors or by just doing the actual division with a calculator, whichever is easier to do in the scenario or just more relevant. Sometimes you can't reduce a fraction, so you have to do the division. Sometimes it could work either way. But before we get into that, I want to show a quick video about having a growth mindset, and you'll hear me say one or two of these things again, per usual, just because I think this is a really good idea to have a growth mindset. So this will be probably the one and only one time that I'll show a whole video taken from your assignments. So let's go ahead and get into it.
So we're continuing to move on. We've done some of this time management stuff, and we've done a whole bunch of these setting up proportions and financial literacy. We spent probably 2 weeks just working on that week alone. So today, what we're going to focus most on is we're going to start out and we're actually going to watch the video from Growth Mindset because it's a 4-minute video and there's no other real questions in here besides just a typed response, which you can always type it and I can go look over it afterwards. I know a couple of you have done that and eventually I catch it. And then after that, we're going to go through arithmetic with units, where this is mainly going to be just dealing with rates. The title is a little misleading. Arithmetic with units, you would think that this is the dimensional analysis, out with the old and with the new stuff, but it's actually just rates for the most part, if not all of them, from what I remember. And I was just looking over them. I don't remember seeing anything but rates. All right, so first, let's go ahead and knock this out. I believe I have the audio set to play.
Do you have a growth mindset? How do you think of intelligence? Do you think you're born with a certain level of intelligence that you can't change much? Or do you think it's something you can work on to develop and grow? Many students think that their level of intelligence is fixed, that they can't do much to change it. This can lead them to feeling that they just aren't smart enough to succeed, especially when courses get more challenging. But what if you knew that no matter who you are, through effort and effective strategies, you can develop your level of intelligence? According to Stanford University psychologist Carol Dweck, how we think about our brains actually affects how well we learn. Dweck says that people generally think with one of two different mindsets, a fixed mindset or a growth mindset. People with a fixed mindset believe that their intelligence is fixed at birth and they can't do much to change it. People with a growth mindset believe that their talents, abilities, and intelligence can be developed in different ways. And you may feel like you have a fixed mindset in some ways and a growth mindset in others. For example, you may think with a fixed mindset that you're just not a math person, but you may adopt a growth mindset with writing, music, sports, or another discipline. In fact, scientists who study the brain have found that the brain is like a muscle. It changes and grows in response to what we do. The harder we work using helpful strategies and the more challenges we face, the stronger and smarter the brain becomes. This is because the brain is made up of cells called neurons, which are connected to each other. As we learn, the number of connections between our neurons also grows. As we continue to exercise our brains, the connections between our neurons grow as well. These new and stronger connections help to make us smarter. Scientists call this concept neuroplasticity. Research shows that students who adopt a growth mindset, who believe that their brains can grow and develop through effort and challenges, actually do better in school. For these students, the goal is not to prove what they already know, but rather to learn and grow. Students with a growth mindset view challenges and mistakes not as proof that they aren't smart enough, but as opportunities to become smarter. The good news is that you can develop a growth mindset. You've taken the first step by learning about some of the science that shows you can grow your brain. The next step is to consider your mindset. If you have some areas in which you think you aren't smart, challenge yourself to learn and grow. Why should you bother? Because if you learn to develop your mindset, you'll persist longer with problems. You'll take on harder challenges and stretch your mental muscle more. You won't be as affected by setbacks, and in the end, you'll learn more. And the effects of changing your mindset can stick with you for years, since you're training your brain to think in a new way.
So I really love that video, and that's why it's one of the few ones that I'll actually play through this. Again, there are other videos in these, time management, growth mindset, those style weeks of homeworks, but this is the one that I always wanted to play, and will play again for the next MDE class, et cetera, because it's so important and true. The brain is absolutely parallel to a muscle. And if you see someone who's lifting, say, 400 pounds at the gym, whether they're squats or deadlifts or whatever, they didn't start with that. They didn't just naturally go to that. And of course, some people are more naturally likely to grow muscle as you practice. But that doesn't mean that someone who is less natural to grow that muscle can't do it. They absolutely can, but you have to invest time and energy, focus, positive attitudes, all of that stuff in one big happy package to be able to grow your muscles. And your mind works the same way. And that's why you hear me say so many times, you've got to put in your 12 hours a week of homework and studying. And it might not just be for this course. You might just go online and find some fun little math game and practice your arithmetic for 15 minutes a day as a warm-up. Just like you might, do some of those warm-up gym exercises from high school or middle school, like the butterfly or the neck twist and all that stuff. And warm-ups are very important. So the same thing can be said about that. I know I'm a math teacher, so it's probably not a surprise, but I do a little bit of arithmetic each day just to keep sharp, just to warm up. I don't want to go straight into doing, advanced numerical calculus without kind of waking myself up for the day, a little stretching, if you will. And a lot of people need more stretching than they realize. So invest that time, try and be a more positive thinker, try and take on that growth mindset. So the 3 questions in here are, more of like a sentence or paragraph, briefly to just explain the difference between a growth mindset and a fixed mindset. Then explain why working on challenging problems causes the brain to grow. And what is one benefit to having a growth mindset versus a fixed mindset? So all of those were answered in the video. I kind of expounded upon a little of them, but I'm not going to just answer them directly because that's up to y'all. And since it's just 3 questions, it's a whole nother story. So again, be positive, try and have that growth mindset. Know that just because you can't do something initially doesn't mean you can't do it ever. You're going to do things wrong to learn how to do them right. All of those things I keep saying, absolutely true. Okay. So with that, oops, I just realized my phone's not on silent. Not that you need to know that, but I don't want to be interrupted. Change that. We are back on arithmetic with units. And we're going to do most, if not all of these, because they're all pretty short. Do I have a calculator up? I do have my calculator up. So these sets of problems, I would love if you were doing these on pencil and paper in addition to just typing them out. Because per usual, my math lab kind of removes the quantitative reasoning student element out of it for a lot of these answers by writing the units in the top and the bottom. But this is the mindset that you have to get into. When they say to write the rate as a fraction in lowest terms, they don't just mean to write 22/6 and reduce the fraction. They mean to write 22 cups, literally, over 6 people, and again, literally. You're supposed to use your words, use your units, because without the units, 22/6 means nothing, or its reduced form, which we'll get to in a minute. So let's do that, and this, boom, there we go, get the pen. So write the rate as a fraction in lowest terms. Now, when they're giving you these simple problems, you need to do the first thing is the top and the second thing is the bottom. And that's pretty common with most of the problems in this course and very often in the real world, but that's not how it has to be. If I ask for a speed in miles per hour, I might give you the distance first, and then, I'm sorry, I might give you the time first and the distance second, or vice versa. So you'd have to understand, well, speed makes more sense as miles per hour, so let me put the distance on top and the time on bottom, or miles on top and hours on bottom. If it's something that you're just doing to find an answer and it doesn't have to be a specific unit, then maybe there's a reason you want to do people over cups instead of cups over people, and you would have that freedom in the real world. But we got to do it their way. So we get 22 cups over 6 people. That's how you should be writing that down. And then you say, oh, well, I recognize 2 goes into both of these. 2 goes into 6 3 times. 2 goes into 22 11 times. And then there's no number that goes into both 3 and 11 besides 1, so that's it. We just have 11 cups per 3 people. So the rate of 22 cups of, say, coffee for 6 people who are going to be very caffeinated, unless it's decaf, saying that rate, if it was a constant proportion, a constant ratio for all coffee and people, say in a day maybe, then saying 22 cups for 6 people has the exact same repercussions as saying 11 cups for 3 people. Because if you give 11 cups to 3 people, then you give 11 cups to 3 more people, that's 22 cups over 6 people. Boom. Now you might say, well, why not write this as a, why didn't you just do the division? Because they didn't ask us to do the division here. They said to write it in lowest terms as a fraction. So that's another case of you have to pay attention to the instructions. Maybe there's a reason we want this just to be in lowest terms, so we can say for every 3 people, we need 11 cups of coffee. Or maybe there would have been a reason to do it as a unit rate, which is where you actually do the division, which for this problem would have been 11 divided by 3. So you do your division, and you say 3.66 or 3.67 if you round to the nearest tenth, instead of 3.666666. And then you say, okay, well, that's 3.66 cups of coffee per person. When you actually do the division, now you're only talking about one of the thing in the bottom, so that would be 3.67 cups of coffee per person instead of 11 cups for 3 people. It's just a different way of thinking about it. Maybe you want to think about it as a per single person. Maybe you want to think about it in just groups of 3s. It depends on the context of the problem. All right, write the following rate in simplest form. And they say to type a whole number or a simplified fraction. Okay, so 266 calories burned in 49 minutes. So maybe you go on a, what would that be? Maybe a medium, light to medium walk, maybe like 3 miles an hour. Now this is generalizing for probably someone in the 150 to 200 pound range. If you're not in that range, if you are heavier than that, you're going to burn more calories if you're moving the same speed because you have more weight to move, and calories burned is a product of lots of different variables, including your own weight. So a 100-pound person who runs 10 miles an hour may burn 100 calories in 1 mile, but a 400-pound, or let's go 300-pound person who runs 10 miles an hour might burn 300 calories in a mile. So write it in simplest form. So they say type a whole number or a simplified fraction. So maybe you think you're just going to divide this and get a whole number. So we can try that. We get 266 divided by 49. Well, shoot, that's not a whole number. And if you do 5.42 anything or 5.43, it's going to be wrong. Maybe you just, oh, they wanted me to round to the nearest 10th or 100th. They just didn't tell me that. And it says it's wrong. Okay, that's because we weren't supposed to do it that way. They asked for it as a unit rate and rounding to a specific place, then that's what we would have wanted. Clear, please. Thank you. So instead, this is like last time where we want to go 200. That was weird. Blue, please. 266 calories divided by 49 minutes. And then just try and figure out what number goes into the top and the bottom. Now you might say, well, maybe 2. Well, sure, 2 goes into the top. 2 goes into 6 3 times, and you can just keep dividing it. You'll get 133. But 2 is not going to go into 49 evenly. And you might say, well, maybe 3 goes into the top. 2 plus 6 is 8. 8 plus 6 is 14. Actually, 3 does not go into it. That's a cool little trick. If you add up the digits of a number and then divide that by 3, if that goes in, that means the original number is divisible by 3. It's a cool little trick that I just did. So I said 2 plus 6 is 8. 8 plus 6 is 14. I can't divide 14 by 3, which means I can't divide 266 by 3. That's the only number with a weird trick like that, dividing by 3. All right, well, maybe you think 4. Well, 2 didn't go into 49, so why would 4? No even numbers are going to go into 49. Maybe 5, definitely not. They don't end in 5 or 0. Maybe you think 10. Well, no, they don't end in 0. Maybe you think 11. Well, definitely not 11. But I skipped one. I skipped 7. Now, 7 definitely goes into 49, so it's just a matter of whether 7 goes into 266. So let's just try it out. 266 divided by 7. And look at that. It goes in 38 times. So 7 goes into 266 38 times, and 7 goes into 49 7 times. There's definitely no number that goes into both 7 and 38, so it'd be 38 over 7 calories per minute, or 38 calories every 7 minutes. 38 slash for the division, 7, that's 7, that's 78. And we got it right. Now, maybe you didn't like doing it that way. There's an alternate way for reducing your fractions. You can prime factorize these, or you can just factor down as much as you see possible. So the 266, I'm just going to focus on the numbers for now. 266 over 49. Well, I know 49 I can write as 7 times 7. And then I can say, all right, well, 7 is the only number that goes in the bottom, so let me see if I can write 7 times something for 266. And we already showed that 7 goes in this 266 38 times, so, oh yeah, it's 38. Then you can cancel a pair of 7s, and you get the same answer, of course, with the units. Excuse me, hold on, I gotta cough worse. Okay, so saying that someone burned 266 calories in 49 minutes, you could say is proportional to someone just burning 38 calories over 7 minutes continuously. So every 7 minutes, you burn 38 calories. 7 more minutes pass, you burn 38 more calories. Another 7 minutes pass, you burn 38 more calories. So once you got up to 49 minutes, if you added that 38 7 times, you'd get 266. Sorry about that. Need a, what do they call it? There's an audio filter where it cuts out if something's too loud. A gate. I need a gate mic. That's what I need, so y'all never hear me cough. Okay, write the rate in simplest form. 5 million hits on a website in 20 months. So they want millions of hits first and then months second. And they wrote the word millions in here, so you don't need to do 5 and then 6 zeros. All right, so we got 5 million hits on a website over 20 months. So we're looking at website activity, and we're trying to break this down ultimately maybe to hits per month. Well, they just want it as a reduced fraction, so maybe not a number of hits per month, because the denominator won't necessarily be 1. I think it's obvious 5 goes into both, 1 and 4 times. That's all you're going to be able to do, which says we were getting 1 million hits every 4 months. So we'll do 1 million hits for every 4 months. Let's see if we get it right. And we did. See, if I had typed a bunch of zeros, let me hit similar question. Now I got 5 million hits over 15 months. So what if I did it this way? I write the number in millions instead of the word millions of hits, and then the 15 months. Oh, well, 5 still goes into both of these. That's kind of cool. So that's 3 now. And then this 5 million is going to become 1 million. So the answer would be 1 million hits over 3 months. So every 3 months we were getting 1 million hits. So if we continue to get the exact same activity, which of course on a website we can't guarantee that every month we get the exact same activity. So this is stretching it a little, but just go with it. So here's what someone might do. 1 million per 3, and they get it wrong and they go, how in the world did I get this wrong? Because I know absolutely I reduced this perfectly. It's 1 million hits every 3 months, and it's because someone didn't pay attention. Because the word million was in there, and then you typed it in millions. They even tell you at least that the denominator is correct. That's kind of nice. Begin by writing the rate as a fraction, then reduce. It doesn't actually clue you in that you did the top wrong, but hopefully you'd realize, well, we got the bottom right. How's the bottom right? The top isn't right. Oh, I see that word million now, so I just needed the 1. There we go. All right, write the following rate in simplest form. So again, type a whole number or a simplified fraction. They're still not getting this as a unit rate. Unit rate means you're going to do the division, absolutely. So 301 points over 28 games. So this sounds like we've got a sports ball person playing, and over 28 games, they scored 301 points. And we're trying to figure out, I would call this more their average if we break this down to a every game basis. Or maybe you just have someone who is scoring the exact same points every single game, and then once they hit that number of points, coach pulls them for some reason. I don't know why they would do that, but just go with it. All right, so 301.28. Well, 2's not going to go into both of those because the top one's odd and the bottom one's even. 3 is not going to go into either of those. It would go into 300, but not 301, and certainly not into 28. 5's not going to go in because they don't end in 5 or 0. So let's try 7 again. So 7 into 301. And I'm seeing some stuff that may or may not be good. I don't want to spoil it though. So we're going to try 301 divided by 7. Let's see what we get. We got 43. So 7 went into these as well as a previous example. Just because a number gets used once doesn't mean it never does again. And 7 goes into 28. 4 times. Why did I write 7 on that top one? Because I said 7, that's why. 7 went into 301 43 times, and 7 goes into 28 4 times. See, again, I am very prone to making mistakes when I talk, think, write at the same speed, especially in this new format. I wasn't this bad on a whiteboard, but my little setup at home is not optimal. So as always, thank you for dealing with me, but I love it because it shows you how we can catch ourselves in mistakes. When I wrote 7, I was like, no, 7 doesn't go into 301 7 times. I instantly knew I had made a simple mistake. So that would be 43 points every 4 games. So let's try that. 43 over 3. I'm hitting the slash key on my keyboard to do that without having to hit the fraction button first. Either way works though. Ooh, we did something wrong, didn't we? And I said it wrong intentionally. I was kind of going with that same vein. I said 43 over 3. Nope, it's 43 over 4. But that one is definitely going to be right. Here we go. See that little simple element, that element of rushing when we're not taking our time can make a major difference. Simple mistakes can make or break you. Thankfully, when you're taking a test, you're not going to be writing and thinking and reading at 3 different speeds. And talking, reading, talking, whatever. All right, the rate in simplest form. So again, numbers top and bottom. So we have dollars over photos. So $56 for 480 photos. So we went to Walgreens or somewhere else and we paid, same thing I keep doing. We paid $56 for 480 photos. Well, they're both even, so 2 definitely goes into both of them. Maybe we could do better though. If 2 goes in, maybe 4 would. Well, 4 definitely goes into 56, and it's definitely going to go into 480. 4 is going to go into 56. Well, 40 would be 10 of them. There's 16 left, so that's 4 more, so 14. 4 will go into 48 12 times, and then we can just tack on a 0, so that should be 120. And maybe you don't trust yourself, or maybe you don't trust me at this point, because maybe I'm fooling you, or maybe I made a goofy little mistake. So you can check with calculators. Nobody's stopping you in here on that. It's the only math class you'll ever hear me say, I don't mind calculators. So 120, because this is math for the real world. So we got $14 for 120 photos. But look at that. Even though I divided by 4, which is better than 2, I can still go further because these are both even. So I can say, oh, okay, well, 2 goes into 14 7 times. 2 will go into 12 6 times. Just tack on the 0 because it's divided evenly. So that'll be 60. And there's definitely no number that goes into both 7 and 60. So that would be $7 for 60 photos. So if Walgreens or Walmart or Wall whatever, if they're charging the same amount per photo, so if one photo costs you, say, $1, 10 photos cost you $10, 100 photos cost you $100, if that's their pricing system, then if you paid 56 for 480 photos, that would have been the same as if you said, I paid $7 for 60 photos. Or you could even do that division if you want the unit rate. And it says you're paying about 12 cents when you round to the nearest penny per photo. But again, they did not ask for a unit rate, so we didn't need to do that. But it's fun, so we did. All right, so what do we get down to? $7 for 60 photos. Let's see, maybe I make a typo. Oh, made a typo. I spoiled that intentionally. 60, 760, 760, double, triple check. Good. Again, I really wish that my math lab did not put these units in there. I wish you had to type them up every time, because that would make you a better quantitative reasoning student. And that's why I say, don't just do your homework and then never actually take any documentation. Write this stuff down, take notes, do all the stuff that I actually do, because things are going to stay in that brain of yours for a longer time. All right, 14 cups for 6 people, 2 goes into both of those, 2 goes into 14.7, 2 goes into 6.3. So that's 7 cups for 3 people, and that's not going to reduce at all. So 7 cups of coffee for 3 people would be the same thing as saying 14 cups of coffee for 6 people. It would be the same thing as saying 21 cups of coffee for 9 people, or 28 cups of coffee for 12 people. It would also be the same if I wanted to break it down into a per person situation. 7 divided by 3, that's 2.33. So that's saying 2.33 cups of coffee per person. Maybe we're talking about the average amount of coffee someone drinks in a day, some big statistic that we studied over 1,000,005 people. And it turns out when we looked at that 1,000,005 people, the average was 2.33 cups of coffee per day. So if I put 3 people in a room, if I assume that they're going to have that average consumption, then I could assume that I need to bring 7 cups of coffee. Now, maybe one of those people is just a true coffee lover. They're on that caffeine train, and they're going to have 7 cups by themselves. Then that's, not going to work in that situation, because I was going based on an average that with people doesn't have to be true. But it's at least a good starting point. I can go, throw another pot on while we wait. And hopefully that person goes, excuse me, Mr. Beckner, you're going to need more coffee from me just by myself. All right. I know, I'm silly. I must have hit similar question, right? No, it was just literally the same question. That's amazing. That, when I did this, when I set this up, these were not the same numbers, but I think I've told you before, the numbers are randomly generated. So let me just get this one wrong, so we can at least get some different numbers. Don't you dare give me 14 and 6 again. Similar question. Similar question. There we go. 14 cups for 4 people. So 2 is going to go into 14 7 times. 2 is going to go into 4 twice. So that would be 7 cups for 2 people, which is a unit rate, turns out to be 3.5. So that problem, now we've got some more caffeine addicted people in the group. All right. 4 pounds of zucchini for 12 servings of food, I guess. All right, let's go back to actually showing the work. I clicked eraser. What is happening? Oh, I know why. I had my pen hovering over the board while I was trying to use my mouse. It's kind of weird. You know what? You don't care. 4 pounds. Now use lbs for pounds. Of zucchini, you can be more specific if you need to, but 4 pounds is good enough for government work. And then over 12 servings. So classic mistake here is someone goes, oh, 12 divided by 4 is 3, and the answer is 3. And, well, 3 is not an answer. You want to say 3 pounds per serving. But that would be wrong because you did the division upside down because you were trying to work too quick and not showing your work and writing your units. So 4 does go into both of these. 4 goes into 4 once and into 12 3 times. But that says that the answer is 1 pound makes 3 servings. That's a lot of zucchini for 1 serving. So 1 pound would make 3 servings of this dish. There we go. And you know, that might sound like a lot of vegetables for 1 serving of food, but it sounds like even more if it's 3 pounds per serving. Is one person going to eat 3 pounds of zucchini in 1 sitting? I mean, I guess if you're a hardcore vegetarian and maybe you're in a food competition or something like that, but can't really think of any other reason to eat that much of a vegetable besides that. I'm also not much of a vegetable eater personally, besides salads, but not while we're here today. All right, getting into the unit rate, something that is more likely how you'll be doing things in the real world outside of the classroom, because you're just going to go to your calculator and do the division. So some person or car or train or airplane went 14,608 kilometers in 83 seconds. And when I said plane, it also could be a spaceship. So let's see, what would the unit rate be? So when we find the unit rate, that's going to give us our speed in terms of an amount of distance every single second that we cover. So we're going to go 146. It's a weird looking 6, wasn't it? 14608 kilometers divided by 83 seconds. Pull out our calculator. No one's doing that division in their head, I don't think. And that's perfectly fine. 14608 divided by 83. And we get 176. So 176 is our answer, right? Nope. Not 176. That is not a quantitative reasoning student answer. It's 176 units, kilometers over seconds. So you could do kilometers per second that way, or you could write it with more words, 176 kilometers per second, or you could go with an abbreviation if everyone is okay with it, kilometers per second. KPS is kilometers per second, just like MPS is miles per second, which that's the only time miles is abbreviated with an M, otherwise it's MI. So this didn't end up being a decimal, but that's fine. It was a whole number. Nobody said it had to be a decimal. So 176 kilometers per second. Now maybe you don't trust that. You're like, holy cow, that is a ridiculously fast speed. We're covering 176 kilometers, which is about 100 miles, 105 miles roughly. We'll do that conversion another day maybe. Wow, a bird just flew into my window really hard. I'm wondering if y'all heard that. I hope he or she's okay. All right, I got distracted. So maybe you don't trust this answer. I showed the math once, but you know what they say, measure twice, cut once. So do it again. 14608. I'm staring at the number to make sure it's right. Okay, we're good. Divided by 83. 176. All right, now I'm trusting it. Now we can hit check, and we got it right. We're doing great. So that's a ridiculously fast speed, but you know, I said it could have been a person or a car or a train or a plane or a spaceship. This is probably a spaceship, or maybe an asteroid or something like that. Certainly wouldn't be a walking speed. All right, 896 kilometers, which is a much smaller distance, over 7 hours, which is a much longer time. See, this last problem was in kilometers per second. We did a whole lot of distance over a very small amount of time. That's 1 minute and 23 seconds. Whereas now we're covering, you know, it's still triple digit kilometers, but over 7 hours. So let's see what we get. 896 kilometers per, so over 7 hours. And let's just do that division. It might divide perfectly. It might be a decimal. Since they don't tell us to round anywhere, I'm going to assume it's not going to go on forever and ever and ever. 896 divided by 7. And we get 128. So we get 128. 128 bobs per orange, right? 128 waters per notebook, right? I'm just looking at things in my room. I don't have a bob in the room, but I do have an orange in the room. No, kilometers per hour, or 128 kph. And see, I wrote my slash vertically. They do theirs horizontally. You could also write it with your words, 128 kilometers per hour. For the 9 millionth time, the word per means the second unit goes where? In the bottom. Good answer. All right, determine the unit rate of the following. Remember, unit rate means you're doing the division. You don't even have to try and reduce it. Just pull out a calculator. 5 yards of material for 2 dresses. So we're working on the outfits for this week's play or this month's play, whatever. 5 yards of material. You can write material if you want, but yards is good enough. And with that 5 yards of material, we need to make 2 dresses. So you go, all right, well, how much material does that mean we have to use on each dress? Because maybe you use 3 yards of material in one dress and you go, well, if they're the same size, do I have enough to make the other? Maybe I need to use less material in the first one. Hint, wink, nudge. And 5 divided by 2, I'm not even going to pull the calculator out for that one. It's, excuse my hiccup, 2.5. So that's 2.5 what? Not yards, yards per dress. Remember, when you do the division, the bottom is automatically a 1. It's 2.5 yards for every 1 dress. It's just nobody writes denominators of 1 in an answer. I did not mean to hit that. I really hope that, there we go, okay. And per usual, ignore the color change. You could write it with words. I don't think there's any formal abbreviation for yards per dress. So that'd be 2.5 yards per dress. Sounds good. Notice they said type a whole number or decimal. If I had typed in 5/2, let's do a similar question. So 3/2 would be 1.5, but look what happens if I type 3/2. They tell me, although your answer is equal to the correct one, it's not in the correct form. You were supposed to pay attention to the instructions. We already did it. Yes, I want to continue. La, 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 la. Another one of those days, apparently. I haven't had any problems so far. I'll make up some more if I have to. I mean, it's just 6 more in here, or 7 more, depending on where did we start. There we go. I think I skipped 12. I'll go back to it. It will probably take 5 minutes to reset. Find the unit price. So this is the type of problem that I referred to in the lecture today when we were talking about grams of protein. So this one is going to be a cost per banana. You might go, well, why isn't it grams? Well, we don't know how many grams we have in these bananas, and bananas are very inconsistent in weight, so you'd have to weigh them all individually and get a total weight there. It was a lot easier when the weights were consistent over servings. And you know, I don't really see a reason to think about a cost per gram of banana. It would be much easier to think about a cost per banana. Going cost per gram in that protein problem made more sense, logistically speaking. So we got $4.25. And that $4.25 bought us 17 bananas of all shapes and sizes. They ask us to do a unit price. They don't say anything about fractions, which means we just do the division. Also, we can't even reduce decimals with fractions anyways. I'd have to make that 425 over 1700 and then reduce, which is just silly. There's no reason a quantitative reasoning student needs that. 4.25 divided by 17, and we get an answer of 0.25. So 0.25 is the answer, right? Nope. It's $0.25, aka 25 cents per banana. And again, you might want to write the one writing it that way, but you're never going to type that in my math lab as a homework quiz test question answer, anything like that. So I kind of prefer it this way, $0.25 or 25 cents per banana. Or it actually looks better with a slash that way. So let's see, 0.25. So I'll write 25. 25, right? 25, right? Nope. What happened? I see a 25 on the screen. Mr. Beckner, you lied to me. Forgot the decimal, didn't he? That clever, mean teacher. 0.25. I don't even have to write the 0 in front of it. And we got it right. All right, so let's go back to number 12. Yes, we did end up skipping it accidentally. All right, that was quicker. Good. So 25 cents a banana. That sounds about right. Bananas tend to be about a half a pound on average. Again, notice I said on average. Don't believe me, go to a grocery store, grab one banana, throw it on the scale if they still have those things out. I haven't even paid attention to that lately. I'd usually just grab and go. It'll probably be in the ballpark of a half a pound, but there are bigger bananas that might be closer to a pound. There are smaller bananas, especially your organic ones, that might be like a quarter or a third of a pound. The bananas are usually pretty cheap, 30, 40, 50 cents a pound. Organic, maybe 80 cents to a pound to $1 a pound, depending on where you're buying them from. If you're buying them from Starbucks, that's a whole nother story. You're paying $1 a banana if I had to guess. Wouldn't know. Don't buy bananas at Starbucks. Don't go to Starbucks. All right, 125 hours of homework for every 5 weeks. So you determine based on your teacher saying, you know, all right, 3 credits in class means spend 6 hours out of class a week doing homework. And you just did some random math and you figure out that, oh, over 5 weeks, I need to be doing 125 hours of studying, homework, writing, reading, studying, homework, writing, reading, whatever. Practice, warm-ups, random arithmetic problems, whatever. Well, 5 clearly goes into both of those, and you can show that reduction, or you go, well, Mr. Beckner said I can have a calculator. I'm just going to use the calculator, and you do 125 divided by 5, and you get 25. So 25 is our answer? Nope. 25 hours per week. 25 hours per week, depending on how you want to write it. 25 hours per week. Again, my math lab doesn't make you have to do enough with this stuff. I dislike it. All right, $130.40 for 8 compact discs. That's another thing about math. You're only supposed to say and for a decimal. So if you have the number, say, 3,024, a lot of people will say 3,024, but that's grammatically incorrect. Now, fortunately, nobody cares, and I'm not going to penalize you for that in this course. But it's just another one of those technicalities, kind of like, oh, it's 68 degrees outside, right? Nope. 68 degrees Celsius, 68 degrees Kelvin. I hope it's neither of those. The first one, we're almost on fire. The second one, we froze hours ago. It's 68 degrees Fahrenheit currently, roughly, which is, you know, a solid temperature for most of us. Of course, that's subjective. All right. So we got $130.40. If you don't like using the dollar symbol when you're writing your rates, you can always write the word dollars or USD. We've demonstrated that in the past for 8. And instead of writing compact disc, we'll write CDs. because someone in here is still buying CDs in this age. Maybe someone is. Couldn't tell you the last time I bought one. I also use YouTube for all my music, so 130.4 divided by 8, and you get 16.3. Oh, I don't trust Mr. Beckner's math. Maybe he typed it wrong. Well, my calculator displays it, 130.4 divided by 8. Well, I'm still going to type it again. 130.4. Cut twice, measure once, right? Nope, he said it in the backwards order. It's measure twice, cut once. 130.4. Don't even have to type that extra 0. Divided by 8. 16.3. Got to stop doing that. Click, then type. 16.3. So that's dollars per CD. So $16.30 per compact disc. Now, if I just write 0.3, it'll still mark it right. But we know with money, we usually write the second decimal place. All right, the store offers honey lemon cough drops as listed below. I think the homework heard me. That's kind of funny. Complete the following table and determine which is the better buy. Ah, this is that protein problem we did in class, but just a little different, a little simpler. No per serving and all that jazz. It just gives you the total all together. So a total price of $1.14 gets you 20 cough drops, or $5.49 gets you 100 cough drops. So that last one, it's very obvious that you're getting 5 times as many cough drops. So if this price is more than 5 times the original cost, then it's the worst value. If it's less than 5 times the original cost, then it's a better value. That's one way you can think of it when these are nice, easy multipliers of each other, but it doesn't always work that way, like the protein problem from class. Okay, so so scenario A, we got $1.14. Now, hold on, before I start that. So far, we've always done first thing over second thing. So far, we've always done first thing over second. But if you do it that way this time, it doesn't quite work as well. It's 20 cough drops over, I'm going to end up erasing this, spoilers, over $1.14. And if you do that division, you'll get an answer that you can still do a cost analysis, but it's backwards from the way I taught in the previous course, because everything's upside down. The 20 divided by 114. Again, I'm going to erase this and start over ultimately. And that says it's 17.54. Is that $17.54 per cough drop? No, that's how many cough drops you get every time you spend $1. $17.54. Oops, I didn't mean to write the slash. That's per drop. Hold on one second. I have a contractor coming to my house, and I'm just making sure he wasn't earlier than he was supposed to be. He's supposed to be here in about 10 minutes. Okay, so is that right? $17.54 per drop? No, that doesn't make any sense because this says you got 20 drops for about $1. So this would not make sense. Again, I'm going to erase this whole thing ultimately. But it's not dollars per drop. It's actually, you get 17.54 drops per dollar. Now, that is a perfectly fine way to do cost analysis, but you actually want more drops per dollar to be the better deal. So this is not the way I do things. Again, it's perfectly fine. Just understand that while our goal is going to be to keep the number small, if you do it this way, you actually want it to be big. You want to get more drops per dollar. All right, so let's not do the first thing over the second thing. Let's remember that cost analysis, the traditional way, again, traditional way, is to do the cost over the number of things, or how much you have of it. This is cost analysis. You take the total cost and you divide it by the number of things, the number of how much weight you have, whatever would be more relevant. So for scenario A, we take its cost, which is $1.14 divided by the 20 drops. And we get 0.057. And since that doesn't keep going, I'm actually going to write the answer that way. So that's $0.057 per drop, which is about 6 cents a drop. Now, again, with money, we traditionally round to 2 decimal places, but I'm not sure, because I haven't done these exact numbers yet, I'm not sure if I'm going to need 2 or 3 decimal places, because maybe they both end up being like 0.06 something when rounded. So for scenario B, we got 100 drops that cost $5.49. So again, we're doing unit cost. That's unit cost. That's what cost analysis is, unit cost. So the total price, which is $5.49, divided by the 100 things, the 100 cough drops. That's $5.49, 5.49 divided by 100. And we get 0.0549. So that's $0.0549 per drop, which is about 5 cents a drop. These things are super close to each other. And yes, if you had rounded this one to the nearest penny, it would be 6 cents. This would be 5 cents, and you would be able to compare them. But they are very close to being incomparable if you round it to the nearest penny. Let's just pretend that this number came out to be 0.056. If you rounded these to the nearest penny, this would have been 0.06, and this would have been 0.06, and it would have been incomparable, which is why I've mentioned that you might need more than 2 decimal places, even though we're talking about money. All right, so our goal is we want the cheaper one, 0.057 versus 0.0549. Well, we're comparing the 4 to the 7. 4 is lower, so this is a cheaper unit cost. All right, so they say to complete the table, round to the nearest cent as needed. So they do tell us to round to 0.06 for the first one and 0.05 for the second one. But those were being very close to being incomparable there, in which case they would have said to round to 3 or 4 decimal places if they needed it. So let's check it. There we go. See, a unit price, once again, has to be the cost divided by the number of things. Again, you can do cost analysis by flipping this upside down, but then instead of wanting the smaller number, the smaller cost per item, you want the greater number because you want to get more items per dollar. So what's the better buy? Just barely, it's better to buy 100 cough drops. So notice I said just barely. Normally what I say is, all right, if you're going to be going through a ton of something over several months or several years, you always want to go with the thing that's cheaper. But this was just barely cheaper. In fact, if you bought 5 of the first thing, you can just take the $1.14 and multiply it by 5. You get $5.70. So it's only a 21 cents different if you're buying them 100 at a time versus 100 at a time in the 5 individual packs. But what if you don't need 100 at a time? What if you need 20 cough drops and then your cough is gone for a year? If you're that type of person, maybe you don't want to be sitting on these bulk cough drops just sitting in the cabinet, 80 cough drops just sitting around. But if you're the type of person who's popping 3, 4, 5 a day every single day, then that would be another scenario. Even though it's barely cheaper, I would buy the ones in bulk. But quite often, you'll find that the difference in a unit cost is further apart than this scenario. It's more like the one we did in my class, where it might be like 5 cents per item for one and 8 cents per item for the other. Now, that might not sound like a big difference, but that is a significant difference as a cost per. But it is another thing to consider. Do you need this item over and over and over and over and over? So if the bulk is cheaper, which it usually is, you know, you don't want to have just say 50 things of toilet paper just sitting around maybe in the Corona days. All right. So we finished that. A long distance phone call between two cities costs $3.50 for 6 minutes. What is the rate in cents per minute? In cents per minute. So we got cost of $3.54 for every 6 minutes. So we can do the division. 354 divided by 6. And we get 59.59. So this is $0.59 per every minute. Or if you write it this way, per minute. Now I'm going to do this wrong. This is wrong. So, oh, it's $0.59 per minute. So I just type my 0.59. I'm rushing. That's not right. And this does not actually give you a clue. Well, actually, yes, it does. Remember, first to convert the dollar to cents. That was the issue here. This answer is in dollars, whereas they want it in cents. Now, this is a pretty easy one for most people. They'll go, oh, well, that's 59 cents very clearly. But let's practice our unit conversions. So what we have here is, and they say to do it first, but you can do it second. There's absolutely nothing wrong with doing it second. So we have dollars per minute. So we're going to multiply by a fraction, out with the old, in with the new. What are we trying to get rid of? We're trying to get rid of the dollars. So the dollars were originally in the top, which means in the multiplier, they need to be in the bottom. And then we go, all right, what are we converting to? We're converting to cents. So the cent unit goes in the top. How many dollars get you how many cents? $1 gets you 100 cents. So then your dollars cancel. 0.59 times 100 is 59. And let's see, what units do we have? Well, the cent unit is still there. That's in the top. The minute unit, nothing happened there. They didn't tell us to go to hours or days or anything like that. So it's 59 cents per minute. And again, I said a lot of you are probably just going to be able to do that one off the cuff. But dimensional analysis or proportions, we could have done it that way too, will get you the right answer. All right, simplify the rate, 45 cups for every 35 people. This is back to not doing the division. So 45 over 35, right? No, write your units, cups for people. I don't remember there being so many cups per people problems in this. 45 and 35, 5 will go into both of those, 9 and 7 times respectively. So it's 9 cups for 7 people. Check. Good. Might as well complete this with only 2 left. This was a much shorter section. I told you the sections are inconsistent with number of problems. Light travels 1,302,000 miles in 7 seconds. Find the rate or speed in miles per second. We are literally about to find light speed right here. So we take the 1,302,000, and that's in miles, and it goes that far over 7 seconds. We're just going to do the division. Doesn't say anything about fractions. 1,302. Watch your numbers. 0, 0, 0 divided by 7. It's 186,000. The miles are still on the top. The seconds are still on the bottom, or it's 186,000 MPS, miles per second. Or you could write the words out, miles, and the word per, and seconds. 186,000. Be careful, if they had the word thousands of miles in there, all I'd type is 186. If they had the word millions of miles in there, I'd type 0.186. All right, a cartridge yield of a computer printer is the number of pages that it'll print before the toner runs out. A cartridge that sells for $89.39 has a yield of 3,000 page. What is the cost per page? Cost per page. Cost goes in the top, page goes in the bottom. Cost goes in top, pages goes in the bottom. So our cost was the $89.39. The number of pages was the 3,000. We're using our words. We'll do our division with our handy dandy calculator. 89.39 divided by 3,000. Boom. 0.02979 blah, blah, blah. And of course they tell us to round to the nearest cent. So it's going to be 0.029. Do we round this? Do we take the 7 and go up and round that 9? Well, yeah, it actually would give us the same answer coincidentally. But no, we're looking at the 9, the thousandths place. That tells us to round up. So the 2 becomes a 3. So it's 0.03. That's dollars per page, or 3 cents a page. So 0.03 dollars per page, aka 3 cents a page. And that's a pretty accurate statement. It's about 3 cents a page to just print anything. Now you might say, well, wouldn't it depend on the amount of ink you use? Absolutely. This is just an average though. All right. So we.
All right, so that'll be everything for the day. Per usual, if you have any questions, you can shoot me an email and then we'll pick up where we left off on Monday. Have a good weekend, everybody.